Conditional probability. So now we're looking at the multiplication law of probabilities. Example 1. So these two probabilities are given, and we have to work out this conditional probability that event B happens given that A has already happened. So we use the formula from the formula book. The probability of A and B is 0.3. The probability of A is 0.7. A simple rearrangement, we solve to get 3/7. Example 2. So the probability that event E happens is 0.4. The probability that event E happens given that H has already happened is no longer 0.4, it's changed, which means that E is conditional on H. So E and H here are not independent. Part B. This time we see that the probability of E and E given H are exactly the same. So H has no influence on E. E and H are independent this time because the probabilities here are the same. Example 3. So we're given some probabilities, including a conditional probability. We're using events C and D. We have to work out the probability of D and C. So we start with the formula, only that we've got some generic letters in the formula. We're using A and B, but we're not using A and B here. We've got D and C. So we have to make some changes. So in our formula, the conditional part from here is C given D in this order. C given D there. C given D, which represents this part of the formula. And we can see from here that event D in our problem is A in the formula, which means I need a D here and I need a D here, which means C, which is B in the formula here, goes here. So we substitute the values in that are given, and the probability of D and C is 0.18. Now it's worth knowing that the probability of D and C and the probability of C and D are exactly the same. So whether you write it like this or this doesn't change anything. These probabilities are the same. However, these are not the same. The probability of C given D and the probability of D given C, these differ, so you can't just change the letters around like you can with this. Part B. So we're looking for a conditional probability this time. So again, we've got the formula, and in the formula the conditional probability part here is what we've been given here, the probability of D given C. So we put that into our equation first. So this time we have event A in the formula, so A is here, here and here. We need to replace that with a C, so C goes here, here and here. So we end up with this. And then this is what we're after. We know this already, it was given. The probability of C and D, or D and C, exactly the same. We know this already from here, 0.18. We substitute the values in and solve. So the probability of D given C is 0.9. Part C, to work out the probability of C or D or both. So this time we use the addition law for probability, and we have all the probabilities that we need. We can just substitute them straight in. We know what they are. So again, we modify the letters. Yeah, that's generic, it's in terms of A and B. We're using event C and D here. And if we calculate everything on the right hand side, we get 0.62. For further practice, try these questions.